Well, that's the other element, that you want this thing to be a certain color and to last, but it has to go through the machine, the blow molded machine, the extruder, whatever it is, and it's got to do it, as you say, over and over and over and over again.
Correct. Yep.
I guess the process. One more question about the process.
Yeah.
You have an order. Okay, we've got to make this certain product for this certain application. It's got to be this color. What goes into the pot to make all this stuff happen?
Well, I assume what you're asking me is we have a customer that comes to us and says, I need this color, and they may give us a Pantone color reference, or they may give us a specific, standard that could be a metal plate that has painted color onto it. So they give us a color standard, and they define what the application is, define the polymer and literally the application. Well, that means that there's a whole lot of questions that we're going to ask them in regards to the application, what the specifications need to be. So when you get into a color match, then we know just by polymer the heat stability factors that you're going to have to program in for the polymer itself. Polyester is processed at about 292 degrees centigrade, which is pretty hot, versus some of the polymers such as PVC is only processed somewhere in the range of about 150, 180 degrees centigrade. So there's a diversity of temperature that you have to consider. When we're going to do a color match, again, I need to know how thick the filament is going to be, if it's going to be textured, because all those affect the color, the appearance of the color, if it's high gloss or if it's a matte gloss. And so the information that we receive is critical, how you correctly design the colorant. And then product performance is that secondary issue that goes back. If I want something to last it's going to be an interior application, the pigments that I use for that and versus something that's going to be an exterior application, it's just different. And so you need to know literally how it's going to be used.
Yeah. How do you precisely match color?
Well, there's two ways to match color. You can just from experience know that if I want to match an orange, then I'm going to take a yellow and I'm going to take a red, and I take combinations, and I should use what is referred to as a red shade yellow, because yellow will always be two shades. You can have a red shade yellow or you can have a green shade yellow. So I'll pick a red shade yellow, and then reds are going to be the same. I have two shade ranges of reds. I'm going to have a yellow shade red or a blue shade red. So if I want an orange, I should pick a red shade yellow and a yellow shade red to make an orange.
Okay.
That's what we refer to as visual color matching. We do a lot of referred to as computer color matching today. You take a spectrophotometer, and there's been work that's done many, many years ago by Campbell, and that was done from a standpoint of a scientific approach, where you characterize and classify pigments with the spectrophotometer. There's different ratios of pigment that you put into the polymer. There's blacks that you add to that, or whites, because it changes the appearance of the color, but it also shows you the strength factors of the color. And so you do what is called characterization of the pigments.
I see.
Put that into a computer program, and then I can take a new standard and take what we refer to as spectral readings on it, and that information is put into the computer, and it will give you a prediction in regards to a color match that says, okay, if you take combinations of all these components that you put into this database, it will tell you which ratios of pigments to use for that color match.
I bet that's been the biggest change in your 41 years in the business, is just the roles, the computerization now plays.
That's true, because when I started, it wasn't too many years after that. It was really in 1973 that we started computer color matching.
Oh, really?
Yeah, so it was shortly after I started that we got into that.
Well, I see. I didn't even know there were computers in 1970s.
They were a different type, but there were computers.
I gotcha. The cost factor.
Yeah.
I mean, I'm sure, and I would maybe equate this with buying a house. Everybody has I really want this list, and I suppose once you see the color, sometimes you modify those wants a little bit. Is it the same way in selecting color?
That's basically true. If someone wants extremely what we refer to as a high chroma, bright red for a specific application, let's say nylon 6, there are only a few pigments that have the thermal stability, and they're going to be organic pigments. They give you, again, a bright high chroma color, what we call maybe a fire engine red. That's a bright color to us. So you have to find a pigment, and it's going to be expensive, and it has to have performance factors still. So normally if you need something that is high chroma and demanding, it has a price to bear in that sense. But if you want a low cost blacks are commodity items in regards to carbon blacks, but there are different ranges of blacks. So it depends on the color that you want for the application.
I gotcha. But some of the colors that we see in carpet then maybe started out, well, I wanted this shade, but it looks like this shade is going to work better in terms of the cost factor.
That's exactly right. And so that's why it's important for us to have, again, when we do the characterization of pigments, we have to have a pretty broad range of pigments that are going to do that. They're performance-driven and also cost-driven. Mm-hmm. Because if we don't have all the information into the data file, then we won't be able to effectively compete.
You talked about computers in the 70s coming in and really changing everything. I suspect there have been other elements, other parts of your business that have come in even of late and have been new innovation and have changed things. What are some of those things?
Well, one of the things that has significant change is just environmental. And perhaps that's not why you asked the question, but that has changed the business significantly over the last 10 or 15 years. Environmental concerns, because there are pigments that we worked with when I started that are no longer commercially used or available because they were viewed as, again, hazardous materials. And so from just that perspective, from health and safety hazard reasons, a lot of the pigments have changed, how you have to handle those materials. And from an environmental perspective of these fluents, etc., waste handling, where are you going to put these materials?
I see, yeah.
So there's been a wealth of change, literally, from that perspective, which is all good and necessary. If I answered your question from a standpoint of just innovation from speed, there have been significant changes in dispersion type of equipment, how you disperse pigments, because that's a necessary part of our business. And I expressed that a little bit earlier when I said, well, it depends on the application. If I have something such as a spun-bonded polypropylene, the thickness of the filament could be somewhere in a range of 8 microns. And that's extremely fine. So the particle size of the pigments, normally what we say is we don't want anything from a the diameter of the pigment particle can't be any higher than 10% of the total diameter of the filament. So that's 0.8 microns is the maximum size of. So it depends on the application.
Yeah,
so dispersion has made a whole lot of changes.
I can see that.
From a